Hello guys, hope you are doing extremely well. Here we are going to continue our Blind 75 series, and from this video we are starting dynamic programming. Here it is the first problem from dynamic programming. It is climbing stairs. Let's get started. It is saying that we are given a staircase. It is having n steps and we have to climb till nth step, and we can take one or two step at a time. And it is asking about how many distinct ways can you climb to the top. So I want to notice you that here it is asking about distinct ways. It is not asking about number of steps, how many number of steps we are going to take to reach to the top. Many people get confused here. I also got confused here for the first time when I was trying this problem. It is not asking about the number of steps, it is asking about number of ways. And one more thing about number of ways, it can never be zero. What is the smallest minimum number of ways we can have? We can have number of ways as minimum number of ways as 1. We cannot have 0. There will always be one way of doing thing. And when it is possible that number of ways is 1, if I am having only one step, then number of ways will be 1. Alright, I don't think here anyone will have doubt here. If the number of steps is 1, then there is only one way to climb it. There is no other way. If there is no step, means the top has been given as 0. So staircase is made up of 0 steps. Then how many number of ways will it to reach the top? Then also there will be 1. There will not be never be 0 way, 0 number of ways. This you need to understand here. It is the main point that number of ways can never be 0. Number of steps can be 0, but number of ways can never be 0. Alright, I hope you understood till now. Now let us try for smaller values of steps. Suppose we have number of steps as 0, 1, 2, 3, 4. So we know that for 0 we'll need one way. For one step we will need one way. For two steps like this, suppose this is the ground level, this is the first step, then second step. How many ways we are going to need here? The first way will be, we will take the second option. We are having two options here of one step and two step at a time. So I have chosen this two step option and I have reached there. This is the one way. Alright, and other way can be like this. So there are only two steps. If you try to find any other way for reaching to the top, I don't think you will find here. Now let's see for the third step. If we include here one more step, then how the number of ways are going to increase. This way will continue like this. This was our first way when we were having only two steps. So it will remain as it is. Now this also, the second one which came this way came like this, and I will take option 1, one step and reach there. So this is another way. Now is there any other way? Let's try. Let's take black this time. I'm taking 1, then 2. I am starting with option of one step, then I am taking two step. So this is my one way. If I want to differentiate these way, I can write like this: way 1, way 2, way 3. Way 1 is consisting of two step, plus one step. Here I am just showing for you, showing it for visualization purpose. This way 1 is like this, 2 step plus 1 step, and way 2 is 1 step plus 1 step plus 1 step. So at the end we are going to have sum as 3 only, 2 plus 1 3, 1 plus 1 plus 1 3, and in way 3, that is the last way, we are making first step as one step, then next step as the second option of 2 steps. Alright. So here there are 3 different ways. Now if I add one more step, then how our number of ways are going to increase? Let me show you. Do I have any other color which I have not used? I have not used blue one. Yes, first we will complete the previous ways which have already arrived till this point. So if we observe here carefully, we will find that we are only required to worry about these 2 steps, the second last 2 steps for reaching the final step, means this one and this step. For finding the number of ways to get to the last step, we need to consider only these 2 steps. Why? Because we know that we can make only 2 types of jumps of 1 step and 2 step. From 2 step we can reach there, from 1 step we can reach there, and we already know the ways up to till here. We already know. Alright. So for the third step, it was for total number of steps as 2, it was 2 here. It was 2 here, and total number of steps as 3. The number of ways was 3 here. So total number of ways for reaching the 4th step will continue. This one in the same color, orange one, will reach there. This will be our first way, and the second way will be this one, red one, and third way will be this black one. Now I have 3 ways from step 3 because I will take step 1 and I will reach at the last step. So there I got 3 ways from this third step. Alright, now I will also get some ways from the second step. Let me show you. Do I have any other color? Let me take from here something like this pink. Alright. So you see, I can reach by taking 2 steps from here, and previously which ways were ending here at step 2, there are only 2 steps ending here. First the direct one, and the second one is by taking 1 step 2 times. So there will be 2 ways. Let me use any other color, dark green. Alright, so there are 2 more ways. So there are total 5 ways. So which were ending at here, I have only continued them to reach the last step. Now you must have understood from this example that for reaching any nth step, we are only worried about n minus 1th and n minus 2nd steps, and as we have summed up the last 2 values to get the number of ways for the next step, we will simply do like this. So this is the recurrence relation I got from here, and I can employ it in my recursion for finding the answer. So let's find out how we can use recursion and this recurrence relation for getting our answer. Let's move on to the code, and here we know that there are three things associated with the recursion that are base case. So first we'll write the base case, and base case will be like this. We know that if n is anyhow becomes 0, we have 0 number of steps, then we have one way. That I told in the starting that this, if you are not understanding it, then you can learn it. If there are 0 number of steps, then always number of ways will be 1. Alright, after that we'll be returning climb stairs n minus 1 plus climb stairs n minus 2, simply like this. And this is it. This is our base case. This is our n minus 1 and n minus 2 are a small calculation, and at the end these are our recursive calls. So there are 3 parts that we have already touched here, and this is it. But as you know, there can be overlapping subproblems which can cause it for showing TLE. Let's try to run it, and what it is saying. Okay, so we have not take care of the case when it will become less than 0. It can also become less than 0. It is the imaginary situation that we will not face. We will always get our number of steps as 1 and greater than that. So when it is less than 0, then we can return 0. There are no ways for climbing negative number of steps. Yes, it is showing as accepted. So here we are handling the negative cases. Definitely it will become negative sometime, because we are reducing the value of n by doing n minus 1 and n minus 2. So when it will become negative, we will simply 1, and it will give us 0 from here. Now let me show you how there are overlapping subproblems present here. Suppose we need to find the number of ways for, say, for 5 steps. Then if we are taking 1 step, then we'll left with the problem of finding out the number of ways for taking the for total number of steps as 4, and here in this case it will be 3 if we take one option as 2 steps at a time. Alright, then again we get 3 and 2. Here we'll get 2 and 1, and here again we'll get 2 and 1, and here we'll get 1 and 0, and here 1 0, and here 0 and minus 1. So what are our base cases? Base case are when we hit 0 or 1, or sorry, not 1, only 0 and any negative value. And you can find out here that there are overlapping subproblems present here, because we have calculated this here, and again we have to calculate for 3. So there is need of using here dynamic programming, so that we will save the answer for this 3 and we will use it for this 3. So we will be using the concept of dynamic programming here, and in all these cases when it is 0, we are reaching base case. From all these we will return 1 1 1, and from minus 1 we will return 0, like this. And when we will calculate this one, we will not calculate again all these ones. There are so many overlapping subproblems. So we are going to use a DP here, like this. Let me make a helper function, when we are using dp. So vector int and dp, and it is going to have how many elements? It is going to have n minus 1, but as at the end we need to find the value for the nth step, so it should have the index as n, so we'll take total size as n plus 1. All right, now I will call my helper function. I will pass n and then this tp, and I will simply return it from here. All right, now int helper function, it will take integer value that is containing total number of steps, then vector of int as reference, and that is our dp. And we'll do the same thing as we have done previously. We'll write base case first, and that will be if n is equals to 0, then return 1. If it is less than 0, then return minus 1. Sorry, 0. There is no minus 1 number of ways, so we'll return 0 here. And then we'll check if the problem is currently present in our dp or not. Like this is dp n not is equals to minus 1, then we'll simply return dpn. Otherwise we'll calculate it. dpn is equals to helper n minus 1 comma dp plus helper n minus 2 comma dp, and we'll return dpn. This is it. This is the first part, our base case, and this is our small calculation. Here we are doing n minus 1 and n minus 2, and these two are the recursive calls. So it is, this helper function is recursive function, and this is it. Now let's try to run it and see if it is working. I have made some mistake, I think some typo. Yes, it should be vector. Yes, it is working fine. Let's try to submit it. Yes, it is successfully accepted. Now let's see its time complexity and space complexity. Straight away we can see that it is taking order of n space complexity, as we are using here the vector of size n, the size of input. And talking about the time complexity, here we are calling this again and again till we are filling this dp. So we'll fill all the indexes here, so we'll touch each index once, so its time complexity is going to be order of n. I hope you understood the problem, and if you like this video, you can consider subscribing my channel. Thank you. We'll meet in the next video.